Hello and welcome. I'm Dr. Pauline Fu. In this lecture, I will present compound interest. At the end of lecture, you would be able to calculate interest rate and number of compounding periods, calculate future value of investments, calculate present value of future sums of money, calculate the long-term promissory notes about their purchase price, solve problem involving in equivalent values. So first, let's compare simple interest and compound interest. Take an example of 10,000 investment. Term is 5 years. Rate is 10% per annum. If it is simple interest, so in year 1, you are going to earn interest 1,000 because you use interest time principle. Okay. Remember the simple interest I equal to PRT. P is the principal, R interest rate, T is the time. Okay. T is 1 year, you plug in. So in year 2, what is the interest? 10% times principal. You still get 1,000, okay, etc. And year 5, you get the same interest because this is the simple interest. Now let's look at the balance. Okay, so at the end of year 1, you're going to have original amount plus interest earned in year 1. So 10,000 plus 1,000, you get 11,000. At the end of year 2, you are going to use the previous balance, 11,000 plus interest earned in year 2, you get 12,000, etc. So at the end of 5-year period, you use the previous balance plus interest earned for year 5, you get balance at the end of year 5. So this is simple interest. If you put money, 10,000 in a bank for 5 years, interest is 10% per annum. At the end of 5 years, you'll get 15,000 on condition that it is simple interest. Now, if you look at compound interest, so at the beginning, you have $10,000. Okay. During year 1, you earn 1,000 interest. At the end of year 1, you have 11,000. Now, when you consider year 2 interest, it is 10%, still the same, but the principal you use at the end of year 1 balance, 11,000. Therefore, your interest in year 2 is 1,100. It is 100 more than the interest when you're in simple interest situation here. Why? Because you use compound interest. And this 10% not only apply for principal, but also apply for the interest earned. Okay. So you keep this pattern. At the end of year 5, you get $16,105. See, it is much better than in simple interest. So that is the comparison between simple interest and compound interest. Compound interest, you also calculate interest under interest. Simple interest, it is only calculate for interest for the principal, original principal. Now, how do we determine the periodic rate of interest? Periodic rate of interest. Okay. We use letter J represent nominal rate, and we use M represent number of compounding periods per year. For example, if interest is compounded annually, M equal to 1. If interest compounded semi-annually, M equal to 2. If interest compounded quarterly, M equal to 4. If interest compounded monthly, M equal to 12. So M represents number of compounding periods per year. Okay. Once you have nominal rate J, M, you can figure out what is the periodic rate I equal to J over M. For example, if you have 10% compounded semi-annually, the periodic rate I equal to 10% divided by 2 equal to 5%. Another example, if you have 12% compounded quarterly, 12% compounded quarterly, what is the periodic interest I? I is annual rate 12% divided by 4. Compounded quarterly means M equal to 4. So periodic rate is 3%. So now, how do we calculate number of compounding periods? Number of compounding periods is represented by letter N. It is number of years in the term multiplied by M. M represents number of compounding periods per year. For example, a loan is provided at 4% compounded semi-annually for 5 years. Calculate N. Okay. So N equal to number of years, it is 5 years, times M. M is number of compounding per year, M equal to 2. When you have compounded semi-annually, M equal to 2. Okay. So the total loan is compounded 10 times over 5-year period. So for compound interest, how do we calculate the future value? Future value. We use this formula. Future value equal to present value times 1 plus I raised to power N. I is the periodic rate of interest. N is number of compounding periods in the term. So let's look at this example. A loan for 5,000 with interest at 7.75 compounded semi-annually is repaid after 5 years, 10 months. What is the amount of interest paid? So the amount of interest paid equal to future value minus present value. So the difference between future value and the present value, that is the interest. We already know present value is 5,000. So we need to figure out future value. How do we figure out future value? We use formula. So future value equal to present value times 1 plus I. I represent periodic rate. raised to power n. N represents number of compounding periods in the term. So interest is compounded semi-annually. Okay. Periodic rate I equal to semi-annual means you divide by 2, you get periodic rate I. So I is 0.03875. Next, we need to figure out what is the term n. Okay. There is a typo here. This should be term n, not mn. A typo. This is term n, not m. M should be equal to 2 because compounded semi-annually. M equal to 2. N equal to 5 year, 10 months, 5 year, 10 months. Okay, and then multiply by 2, that is n. Why? Because interest is compounded semi-annually. Okay, we want to know 5 year, 10 months equal to how many half year? The result is 11.666 half year. So this number is n, and you plug in PV, 1 plus I raised to power n, you get a future value. Once you get future value, subtract 5,000 from the future value, you get interest paid. Okay. In this step, when you calculate this step, you can use a calculator. Any calculator can do this calculation. So now I'm going to show you financial calculator. So I want to calculate, how do I figure out this one in a calculator, okay? So first, you can punch in 5,000 times bracket 1.03875 raised to power. The calculator raised to power means yx. Yx is raised to power 11.6, okay. Closing bracket, quick equal. Okay, so you get this number. It is not the same as this number. I'll double check second page. So 5,000 times bracket 1.03875 raised to power plus yxk, then 11.6 closing bracket equal. It still didn't get this number. So I'm going to use Excel to verify what happened here. So equal 5,000 times bracket equal 5,000 times 1.03875 raised to power. Oh, I know the reason. 11.6, it should be 11.66666 is repeating. Okay, so you should enter more digit for 6, 11.66666667. Okay, so this number agree with this one here. So in the calculator, instead of 11.6, I should type in 11.6666. Okay, so I'm going to redo it here. Again, 5,000 times bracket 1.03875 raised to power yx, and then 11.666667. Okay, and then click equal key. So now this number agree with this number. Okay, so this method we use formula. We call this actually based on formula method. Now I'm going to use calculator to do it. Okay, for calculator you need to make sure second quit to clear any previous entries, and then you need to set up PY and CY. Okay, this question said interest compounded semi-annually. In this financial calculator, we use CY represent interest conversion period per year. It is actually M. M represent number of compounding periods per year, but calculator use CY, different notation, same meaning. Okay, so I'm going to set second PY. In this chapter, PY also equal to CY, but when we do the annuity in the following lectures, PY not equal to CY. Okay. So PY equal to 2. Just remember in this chapter, PY equal to CY. So enter. Down arrow key, you have CY 2. Enter. So second quit. Now enter 5,000. 5,000 is present value PV. 7.75. 7.75. When you use calculator, you directly type in nominal rate without percentage. It is just 7.75 without percentage. So IY represent rate, nominal rate. Okay. And then you need to type in term N. 5 years, 10 months is the same as 11.6667 half years. Okay, so type 11.666667. This is term N. Term N. And when you use financial calculator, there are five important buttons. Term N, nominal rate IY, present value PV, monthly payment or periodic payment PMT, FV, future value. Out of these 5 buttons, you must enter 4 numbers. You must enter 4 numbers. So far, we entered 3 numbers. We entered N, IY, PV. Next number, 0 PMT, because you don't make regular payment. You just put this money in the bank for 5 years and 10 months. Okay. PMT is 0. Final step, compute FV. Okay, see, this number agree with this number. You can forget the negative sign. It just indicates this is the money, this is the loan, okay, not the money you have. This is the money you borrowed. Okay. So this is a calculator method. In Excel, you can use the formula. Okay. Try to increase font size. Font size. Okay. just adjust my window so that you can see the questions and the Excel formula. All right, so the question is here, and in Excel you type in FV, future value. Rate, in Excel you have to type in periodic rate, means 7.75% divided by 2. This is periodic rate. NPER, it is 11.666667 is NPER. PMT 0, PV is the present value. In order to get positive result, you can put negative 5,000 because this is the money you borrowed. Okay, type is 0. 0 means at the end you can omit here. So see, this is a Excel method. The formula is here. Okay, you get the same answer as this calculator. So that is the how to calculate future value of compound interest. So now another example. A deposit of 5,000 earns interest at 7% compounded quarterly for 4 years, 4 years and 5 months. At that time, interest rate changes to 6% compounded monthly. What is the value of deposit 3 years after the change in the rate of interest? So in this question, we need to do 2 steps. Step 1, there's a noise here. I need to close my door. Okay, I'll be back in 1 second. Okay, sorry, I just closed my door. Reduce some noise. So a deposit of 5,000. This is the present value. Okay, this is now deposited for 4 years and 5 months. 4 years and 5 months. Okay, 5 months. And the interest is 7% during this time period. So now interest has changed to 6%. And then after interest changed to 3%, this period happened in 3-year period. And the question asks you, what is the money here? What is the future value here? That is the question at this point. So interest rate is 6% compounded monthly. Okay, this is the picture. So we need to do 2 steps. Step 1, what is the future value here? What is the future value after 4 years, 5 months? Okay, this is step 1. And then once you calculated future value after 4 years and 5 months, this number becomes present value relative to this point here. Okay, so you use this number you calculated here as present value, then you figure out future value here. That is step 2. Try to use the same color. That is step 2. And in step 2, interest is compounded monthly. Okay, compounded monthly. So the periodic rate R equal to 6% divided by 12 compounded monthly. Periodic rate I. Term N equal to 3 years, number of years times compounding period per year, 36, means 3 years has 36 months. 36 months. Now going back to here, this 7% is compounded quarterly, means periodic rate I equal to 7% divided by 4. That is compounded quarterly. And the term N equal to 4 year 5 months. So 4 year 5 months. 4 year has how many quarters? 4 year has 4 times 4. 4 year is 16 quarters because 1 year has 4 quarters. 4 year has 16 quarters. So 5 months is how many quarters? 5 months is how many quarters? So you use 5 divided by 4, you get quarters for 5 months. This together is term N. So it is 4 times 4, 16, 16, and this number 4, then 17.125. So what is 4? What is 4? 5 divided by 4? 1.25 plus 6. Okay, so this one equal to 17.25. Okay, so now I'm going to use Excel to do it first, then I will use financial calculator. Finally, I will use formula. So 3 different methods to solve this question. So first, I'm going to use Excel. To do it. Try to adjust my screen. So step 1, I will do it here. This step 1. What is the future value after 4 years, 5 months? So equal FV rate is 7% divided by 4. That is the periodic rate. NPER 17.25. PMT 0. PV negative 5,000. Okay, so this is step 1 at this point. Okay, now step 2. What is the value, the blue point here? FV rate. Rate is 6% divided by 12. Oops. Something goes wrong. Excuse me, my little doggy is you enter too many parameters. Okay, I'll be right back. Little doggy, my little doggy. Okay, you stay here, okay? Okay, sorry for the interruption. So this is step 1. Step 2 equal to FV rate is 6% compounded monthly. NPER is 36. PMT is 0. PV, okay, PV, this PV is this number. So 6,744 becomes present value during this 3-year period. Okay, that's it. So we get step 2. This is the final answer. Final answer. Okay. And this is the Excel method. Now, calculator method. For calculator method, we still use 2 steps. Step 1, what is future value after 4 years, 5 months? And during this period, interest compounded quarterly. So we have to set up PY equal to 4, CY equal to 4. So second quit. Second PY is 4. Enter. Down arrow key, CY is 4. It's already 4, that's fine. So second quit. Now enter 5,000. That is the present value, PV. Okay. 7 is rate, RUY. Okay. 17.25 is a term N. 0 PMT, compute, FV. This is FV. Okay. This is step 1. Now our store, this value becomes PV in step 2. So I'm going to store this value, the result here. Later on, I can recall number 1, it will give me this number. So anyway, I finish step 1. Now I do step 2. In step 2, interest is compounded monthly. So PY equal to 12, CY equal to 12. I go to second, PY 12, enter. Then down arrow key, CY 12. Second, quit. Okay. And now, in step 2, I need to recall this button. This number is present value. So I press PV, present value. And in step 2, it is 6% annual rate. So 6 is RUY. And in step 2, N is 36. 36 is N. Don't forget, you need to put down 4 numbers. So 0 PMT. Finally, compute FV. Okay, just agree with the number here, final answer here. Okay, so I'm going to copy this one. Oh, I don't need to copy. So I did 2 methods, Excel method, calculator method. Now I will present formula method. So this is the formula method. And in formula method, looks like the number has so in formula method, if you compare the numbers, they are different. I will double check why. There are, see, my Excel method agree with my calculator method, but they are different from formula method. I guess when they do this formula method, so I'm going to check here, 17.6. Oh, they get the 17 point, the term N, I have to double check here. The term N, here, I'll double check term N in step 1. So 4 years, 5 months equal to how many quarters? That is the question. So 4 years equal to 16 quarters, no problem. 5 months, 5 months equal to how many quarters? Oh, this one I should divide it by, because a quarter has 3 months, not 4 months. I made mistake here. Apologize. So I'm going to, that is the reason why my result didn't agree with the PowerPoint result. The reason is good lesson. This should be divided by 3, not 4. Why? A quarter has 3 months. So 5 months is 5 divided 3 quarters. Okay, so the result should be 5 divided 3, not 4. So 1.666 minus 6. So this should be 17.6666666 is repeating. Okay, so maybe enter this number as n. And now I will modify my Excel here. So I'll just change the term to 17.6666667. Okay, that's it. And it will automatically change the second number. That is the beauty of using Excel. I didn't change the second one, just change the first one. The second one is automatically updated. Okay, so this is how do I change this one here? For this one, I just changed the term. I have to redo it all over again for this one. So I'm going to quickly go through it. So step 1, I will redo calculator method. Okay. So step 1, it is Py is 4, Cy is 4. So second Py, second quit, then second Py is 4, enter. Down arrow, okay, Cy is 4, second quit, 5,000, that is a present value, 7 is IY, 17.66667, that is the term N, 0 is PMT, compute FV. Okay, so it is this number, 6,793. Now store this number in number 1 here and do the step 2. In step 2, compounded monthly means PY equal to 12, enter. Cy equal to 12, so second quit, and then recall number 1, recall this number. This number is present value, okay? And 6 is interest. I, 36 is term N, 0 PMT. Finally, compute FV. Okay, $8,129. Okay, agree with this number here. Okay, and those results will agree with the formula result here. If you use formula, those are the results. See, agree with this one here. Okay, 2 steps. So that is a little bit complicated questions about future value. There are 2 steps involved, and they use different interest and also different compounding. Oh, by the way, there's, okay, that's fine. So far we talked about future value. How about present value? You rearrange the formula, you will get the present value formula is this one here. Okay, so let's take a look at example. Calculate the principal. That will amount to 20,000 in 6 years at 4% compounded quarterly. So the question asks you, what is the PV? And given the future value is 10,000 is given. Future value is 10,000. Okay. Term interest is compounded quarterly. So periodic rate I equal to 4% divided by 4, 1%. equal to 0.01. And the term N, so 4 year is how many quarter? 1 year has 4 quarters, so 6 times 4. 6 years has 24 quarters. Okay, and then you plug in this formula, FV 10,000, I 0.01, N 24. You get present value. Okay, and you can use a calculator. There is a manual case chalk. How do you calculate this one here? Just follow this step here. I will show you. Okay, here. Second quit. Okay, so 1,000 or 10,000. 10,000 divided by bracket 1.01 raised to power, this yx is raised to power 24, closing bracket, and then press equal. Okay, you get this number. Okay, so this is a calculation by hand. Okay, and now if you want to use financial calculation, how do we do it? So second quit. So first set PY equal to 4, CY equal to 4, because it is compounded quarterly. So second PY 4, enter, down arrow key, CY 4, second quit, and now enter future value 10,000. This is future value FV, okay, and 4 is IY, annual rate, okay, and then 24 is a term N. Remember, you need to enter 4 numbers. So 0 is a PMT, compute PV. So you get this number, 7,875. Okay. So this is a calculator, financial calculator. Similarly, you can use Excel to do it. I will use this position here. Okay. So Excel is PV, present value. So rate is 4% divided by 4, compounded quarterly. NPER 24, PMT 0. Future value is 10,000, and enter. Okay, you get this number. Okay. So this is again 3 methods to figure out the present value of if given future value, what is the present value? We use 3 methods. Okay. So next, we are going to take a look at some applications in promissory notes, discounting interest-bearing promissory notes. Example, calculate the proceeds. Usually the proceeds means the present value. The present value. Calculate the present value of the terminology says proceeds. So calculate the proceeds of a 6-year 900 note bearing interest at 10% compounded quarterly, issued June 1st, 2023, discounted on December 1st, 2028 to yield 8.5% compounded semi-annually. Okay, so let's draw a time diagram. So first, I will label June 1st, 2023. Okay, this note is 6 years. So after 6 years, it will become June 1st, 2029. I will extend this because I need more space here. So after 6 years, the time becomes June 1st, 2029. Okay, so calculate the proceeds varying interest at 10% compounded quarterly. Okay, issued here. This is the issue date, and then discounted on December. So here it is discounted in December 1st, 2028 to yield 8.5% compounded semi-annually. Okay, so this is the diagram, and in terms of this, where is this 900 seated? This 900 seated here. Okay, so this notes as 900, and then the proceeds means what is the present value here? That is the question. What is the present on this point, at this point? So there are two steps. Step one, from here to here. When you have 900 as present value, you can calculate the amount, the value here, right? Step one. And step two, from here to here. Once you have a value here, what is the value here? Step two. Okay, so step one is this one here in red color. So from here to here is step one, calculate future value here. And step two, once you have this future value, you calculate present value at this point. Okay. So this time let's take a look at formula method. Okay. So again, it is labeled here. Okay. So 900 is here. This is the discount date. We call this one is a discount period. Okay. So step one, we want to find step one. What is the maturity value on June 1st, 2019? So step one, from here to here. This is step one. It is 6 years, but interest is compounded quarterly. See, compounded quarterly. So 6 years is the same as 24 quarter. Step one, it is 24 quarter. Okay, so we get the number here. Okay, so this number, $1,627 is here, $1,627. Okay, we get this number. Once we get this number, step two, what is the value here? What is the value here? Step two. Okay, so this we need to figure out the present value relative to this point. Okay. So we use the present value formula. See, present value formula. Present value equal to FV 1 plus I raised to power negative n. There are two formats for the present value formula. One formula said PV equal to FV over 1 plus I raised to power n. This formula is the same as PV equal to FV times 1 plus I raised to power negative n. Okay, so present value equal to here. Okay, so how do we know the term n? From here to here, it is 6 months. During this period, interest is compounded semi-annually. interest is compounded semi-annually. That's why n equal to 1 from here to here, n equal to 1. Okay, and interest is compounded semi-annually. You use 8.5% divided by 2. Okay. So those are the formula method. Now I'm going to use calculator method. So I'll go back to original question. Maybe make a note here. During step 1, from June 1st, 2023 to June 1st, 2029, it is compounded quarterly. So we need to figure out what is the n for step 1, 6 months or 6 years times 4, n equal to 24 quarters. 24 quarters. Okay. And in step 2, interest is compounded semi-annually. So from December 2028 to June 1st, 2029, there are 6 months. 6 months is the same as n equal to 1 because compounded semi-annually. Okay. So now I'm going to use my Excel. Not Excel, sorry. Use calculator. So second quit. Okay. Second quit. Do step 1. What is the future value at this point? Okay. So we need to set up PY is 4. CY is 4. Okay. So second PY 4. Down arrow key CY 4. Second quit 900. 900 is PV, present value. Okay. 10 is interest, I. 24 is a term, N. 0, PMT. Oops, I messed up. 0 is a PMT. So I'm going to redo it. 0 is a PMT. Okay. And then compute FV. I get this number at this point, step 1. Now, this number still is future value relative to this point, so I don't need to store value. It is future value here. I need to store it because I need to reset my PY and CY here. Okay, so I'm going to store in this location that value. Now, second quit for step 2. PY is 2. Enter. Down arrow key. CY is 2. Second quit. Okay. And then recall 1. So this number is FV. FV 8.5. 8.5 is IY. 1 is N. 0 PMT. Compute PV. This is the answer. Okay. So we can check with the solution here. Yes, it is the same answer. See, 1561, 1561. Okay. Similarly, you can use Excel. Go back so that you see the numbers. Here, this is original questions. I will use Excel. In Excel, I will first do step 1. What is the value here? Okay, so future value rate is 10% compounded quarterly divided by 4. NPER 24, PMT 0, PV negative 900. So I get future value. Now step 2, I will calculate this present value here, equal PV, present value. Rate is 8.5% compounded semi-annually, means divided by 2. NPER is 1, PMT 0, future value, I will use this one. Maybe I'll put negative, I want to get positive result. So I will quick cell A1, that is the future value. And this is the number. Agree with this number here. Okay. So that is the discounting interest bearing promissory notes. Promissory notes. So last topic, equivalent payment. Example, date payment of 500 due 3 months ago, 1,000 due today, 2,000 due in 15 months are to be combined into one payment due 6 months from today at 12% compounded monthly. The question is, what is the size of payment here? So this is today. Today. 3 months ago, 500 is due. Today, 1,000 is due. 12 months from today, 2,000 is due. What is the equivalent payment here? 6 months from today, that is the question. Okay. So the analysis is here. You compute what is the future value for this $500 at this point. What is the future value for this $1,000 at this point? And for this $2,000, what is the present value at this point? Then you add all these three numbers together. That is the answer for equivalent payment. Equivalent payment. Okay. So let's do it. Maybe in Excel. Okay. So I'm going to maybe delete those two. So first I will calculate E1. Okay, E1. Interest is what is the interest? I have to read original question. Interest is 12% compounded monthly. 12% compounded monthly. So this is original question. Maybe I will use this diagram so that you can compare. So I want to do E1 first. So E1 is the future value of $500. Interest is 12% compounded monthly. So 12% divided by 12. NPER. So 3 months ago, then 6 months later, there are 9 months for E1 here. From here to here, 9 months. Okay, so type in 9. PMT is 0. Present value negative 300. So this is E1. Okay. Now I'm going to calculate E2. E2 is this $1,000 today future value. Okay. So equal FV, rate still 12%, compounded monthly. NPER is 6 months. PMT 0. PV is 1,000. I will put negative so that the result is positive. So this is E2. Okay. Now I will do the E3. E3 is the present, oh sorry, this one, yeah, it's correct, FV, correct, FV. Now E3 is PV, present value. okay, of this $2,000. So PV rate still 12% compounded monthly. NPER, so from here to here, how many months? From this point to this point, how many months? It is 15 months minus 6 months. So 15 months minus 6 months, it is here. Okay, so 9 months. Okay. 9 is NPER, 0 PMT. Oops, future value is 2000. I will give it negative 2000. I want to get positive result. So I get E3. So finally, you add all these three numbers and this final answer. Okay, I'll check with the solution. I don't have solution. I'm pretty sure. Okay, that is the answer. So, in summary, what I have done in this lecture, I presented compound interest. Specifically, I calculated the future value, the present value, and also interest bearing promissory notes. Lastly, I calculated the equivalent payment. Thank you so much for this lecture. I look forward to see you next time.